In this module, you will learn about Bohr's atomic model. Thomson's student, Ernest Rutherford, conducted an experiment using gold foil, which disproved Thomson's model. For his experiment, Rutherford used a gold foil which was about 1,000 atoms thick. He made a narrow beam of alpha particles fall on the gold foil. Alpha particles are doubly charged helium ions and have a mass of 4 atomic mass units. The result of the experiment was unexpected, as it did not follow the structure of an atom as known to scientists at that time. Rutherford found that most of the alpha particles passed straight through the gold foil without getting deflected. A small fraction of the alpha particles were deflected through small angles. A few alpha particles bounced back. Based on these observations, Rutherford concluded that most of the space inside an atom is empty, as most of the alpha particles pass through the foil without getting reflected. Very few particles were deflected from their path. This deflection was caused by the repulsive force of the positive charge in the atom. The positive charge was concentrated in a small area within the atom and was not spread throughout the atom as Thomson had proposed. Based on his observation, Rutherford proposed the nuclear model of an atom. The positive charge is concentrated in the center of the atom, which is called the nucleus. The electrons revolve around the nucleus in circular paths called orbits. The nucleus is much smaller in size than the atom. According to Rutherford's model, the electrons, while moving in their orbits, would give up energy. This would make them slow down gradually and move towards the nucleus. The electrons will follow a spiral path and then fall into the nucleus. Ultimately, the atom would collapse. In reality, however, an atom is stable. Therefore, this particular assumption made by Rutherford was inaccurate. Keeping the shortcomings of the Rutherford's model in mind, Niels Bohr formed his postulates about the structure of an atom. Electrons revolve in discrete shells called orbits. Electrons revolve in their orbits without radiating energy. Within a particular orbit, the energy of an electron is constant. This is why orbits are called stationary orbits or stationary shells. Orbits or shells are also known as energy levels. Shells are represented by the letters K, L, M, N, or the numbers 1, 2, 3, 4, and so on, depending on the number of shells in the atom. However, Bohr's model did not apply to elements like helium and lithium. The model was also unable to explain the structure of chemical bonds. Despite the limitations of their atomic models, the work of Thomson, Rutherford, and Bohr is considered path-breaking. All three scientists received Nobel Prizes for their theories. As a result, these three atomic models are the foundations for our present-day understanding of the structure